For our second example function, we're going to create our own sum. Of course, we can't just call it sum. We're going to have to call it something a little different. So let's look at exactly what we're expected to do here. And it's pretty obvious. We're to get a list of numbers. It can be integers or floats in that regard. And we are going to return a result once again, and this is a single number. So we have one constraint here, and that is if we reach a variable that is not a number, it is not an int, it is not a float, then we need to break out of it and just return what we have. We're going to stop, we're going to print an error, and then we're going to send back what we had before the error was printed. Usually this is not what you want to do. Normally, if you run into an error, you want to send back some error code. But we're going to do something a little bit more simple. So I want to say our inputs is, numbers, the list, and our output is result, a number. So now we do def sum of list. We put our parameter numbers in here, and I'm going to scroll down so I don't have to look down so much. So we have our list of numbers, and now we're going to have we have to call it result. We set this to 0 because at the outset we have nothing. We're going to say for number in numbers. And now we have to use the type function to determine whether our number here that we're working with is an actual number. So what we do is say type number double equals int or type number equals float. Yes, you could store it. This is okay. Actually, no, it isn't. So what I'm going to do is I'm going to come up here. Number type equals type number. A little bit weird, but this way we're not calling the same function twice. Number type, copy, and we're going to come over here and paste it. So if number type equals int or number type equals float, then we want to do result plus equals number. Else I'm going to print an error message saying a non-number value was found. Then we're going to break. And then either way, whichever one of these goes through, whether we make it to the end of our list of numbers or if we run into this break, we are done and we return result. This function is done. Now let's do some sample output. Sum of list, and we're going to say 1, 2, 3, 4, 5. This is going to give us 1 plus 2 is 3, 6, 10, 15. So we're going to save. I'm going to go back to our command prompt. We're going to run it, and it's going to give us 15. Now let's test it in another way. Print sum of list. 1, 3, 2.65. Oh, sure. 3.14. That'll be it. So now we've got a mix of ints and floats, and this is going to work as well. Now we're going to do a third output. Sum of list 3, 5, 2 as a string. Now this is going to return 8, but it's also going to print an error. So we see how this function can work. Alternatively, one thing we could do, if we did want to return some error code, what we do here is we say result equals -1. And -1 in our case is code for something went wrong. And now if we print this again, it's going to return our -1 code. So another thing you'll see very commonly is your caller is going to check for the error code and print the message accordingly. But again, keeping things nice and simple here. So that's going to do it for our custom sum function. Next time, we're going to do a mean and range. We're going to take information from a list, and we are going to return a dictionary containing 2 values. So stick around for that.